Hello everyone. In this session, we will try to discuss about the vane pumps and also the piston pumps. The vane pumps, the main component of the vane pump is the cam surface and the rotor. The rotor contains of the radial slots, which is nothing but something like a spline to the driving shaft, or it may be for the driven shaft. The rotor rotates inside the cam ring, and each radial slot consists of the vanes, which is freely sliding in and out of the slots due to the centrifugal force which has been created due to the rotation of the shaft. The vane pumps are classified as unbalanced vane pumps and as well as a balanced vane pumps. In the case of the unbalanced vane pumps, it is been classified as fixed displacement pumps and as well as the variable displacement pumps. The first topic what we are discussing is with respect to the unbalanced fixed displacement vane pumps. The main component of the pumps is nothing but a cam surface and as well as a rotor. The rotor consists of the radial slots, which consists of the splines which is mounted on the driving shaft, which is moving in and out due to the rotation of the shaft, or because of the centrifugal force which has been created by the shaft. The cam ring axis is offset to the driving shaft axis. When the rotor rotates, the centrifugal force pushes the vane out against the surface of the cam ring. The vane divides the space between the rotor and as well as the cam ring into a series of small chambers. In these chambers, the fluid, or it may be the hydraulic or the oil, is collected. The same oil is transferred from the inlet to the outlet. During the first half of the rotation, the volume of these chambers increases, thereby causing the reduction of the pressure. This is the suction process which causes the fluid to flow through the inlet port. During the second half of the rotation, the cam ring pushes the vane back into the slot, and as well as the trapped volume of the oil is also reduced. This positively ejects the trapped fluid through the outlet port. The delivered rate of the pump depends upon the eccentricity of the rotor with respect to the cam ring. The schematic diagram shows the vane pumps. Even here also, the vane pumps, normally what we are discussing is with respect to the unbalanced vane pump. In this case, the outer part is called as a cam ring. The inner part is called as a rotor. The outer part is connected to the inlet port and as well as the outlet port. The inner part, which is nothing but a rotor. The rotor consists of the slots. In the slots, the vanes are being placed. The movement of the vanes, it can be done in the two ways. Either it may be by the spring action, or because of the rotation of the shaft, the centrifugal force is created. This centrifugal force, what it has been created, that moves the vane from the slot. The movement of the in and out is a continuous process by which the fluid collection inside the veins or in between the veins is done, and that fluid is thrown out from the inlet port to the outlet port. The process is completed. One side of the cam ring, where the fluid collection is taking place. In the other side, the cam ring, as it is having a contact with the rotor. Along with the rotor, the vanes is pushed in. The movement of the vane, either in and out, makes the fluid flow from the inlet port to the outlet port. The next part what we are discussing is with respect to the unbalanced pressure compensated variable displacement vane pump. See, the schematic diagram shows the variable displacement pump features can be brought into a vane pump by varying the eccentrically between the rotor and as well as the cam ring. Here in this pump, a starter ring is held against the spring-loaded piston. The system pressure acts directly through the hydraulic piston on the right side. This force of the cam ring against the spring load piston on the left side. If the discharge pressure is large enough, it overcomes to compensate it, the spring force, and the shifts the cam ring to the left. This reduces the eccentricity and decreases the flow. If the pressure continues to increase, there is no eccentricity in the pump. Pump flow becomes zero. See, the schematic diagram shows the unbalanced type of the vane pump. See, the left side is nothing but a compensator by means of the spring load. The right side is nothing but a compensator by means of the a piston and a cylinder mechanism. Even here also, it consists of the cam ring and as well as a rotor. The rotor consists of the vanes. The movement of the vanes in and out inside this slot is done because of the centrifugal action. As you know that the vane pumps is used for the high pressure. If the pressure is increased to compensate the piston and as well as the springs are used. The next topic what we are discussing is with respect to the balanced vane pumps. The balanced vane pumps construction features is little complicated when compared to the normal vane pump, or it may be a unbalanced vane pump. The rotor and as well as the casings are on the same central line. Even the what we can say the cam ring and as well as the rotor axis, both it will be on the same straight line. The vane pumps are provided with a slots on the rotor. There are two inlets and as well as the two outlet chambers around the elliptical cam ring surface. The inlet and as well as the outlet chamber are positioned diagonally opposite to each other. The cam ring is elliptical in shape so that the vane stroke is twice the revolution of the pump shaft. The cam ring is elliptical in shape. Thus the volume increases and as well as the decreases at the inlet and as well as the outlet chamber also occur the twice per revolution. In fact, the inlet and as well as the outlet port are connected to a common inlet and as well as outlet within the pump housing. In the operation, due to the elliptical shape of the cam ring, the oil suction at the inlet and the pumping at the outlet occurs simultaneously. The flow of the fluid from the inlet and as well as outlet is a continuous process. But these two, it is at the as it is placed diagonally opposite. In one portion, the inlet is taking place at one diagonal end. The outlet is is taking place. This situation results in an equal pressure and on the opposite side of the pump. The net force acting on the bearing is also zero, or it will be zero because of the what we can say the balanced flow what it is taking place from the inlet and as well as the outlet, which is diagonally opposite. Thus, in terms of the termed as the balanced vane pumps, consequently the life of this type of pump is more, and also application has been exponentially good. The operating time is somewhere around 24,000 hours in the case of the industrial applications. The schematic diagram shows the balanced vane pump. The balanced vane pump consists of the inlet and as well as the outlet. The top portion is nothing but the inlet and the bottom portion is nothing but the outlet. The inlet port consists of the two chambers which are diagonally connected. These two diagonally connected in an opposite direction. The outlet port is also diagonally connected by a line. Once if the rotor starts rotating it, the vanes starts moving in and out. The vane movement is also either it may be because of the spring or by means of the centrifugal force. Both the rotor and as well as the cam ring axis, it lies on the same straight line. But in the case of the unbalanced type, there is an eccentricity. This what we can say the rotor and as well as the cam ring both are placed on the same axis. the wear and tear is very minimum. In the two strokes, or it may be in one rotation, the twice the supply of the fluid takes place. As we know that the on the sides of the, what we can say, the diagonally opposite on the elliptical shape, there is a something like a circular grooves. In this circular grooves, the oils are filled. The oils which has been filled from the inlet is carried by the veins. These veins will transfer the oil from the one chamber to the another chamber which is placed diagonally opposite. So this process is continuous because of the rotation of the uh, because of the rotation of the rotor. The movement of the vanes, it is taking place in and out. As it is taking place in and out twice in one rotation, even what we can say, the supply of the fluid or the hydraulic oil is a continuous process.